this area. We have to see that there is no dust particles here, and then once it comes inside, before placing it to the detector, what I'll do is I'll take a piece of tissue paper, put some isopropanol in it, and clean it thoroughly. Okay, clean it thoroughly, both the sides, and then isopropanol or acetone is better because it dries faster. So now it is done. So this sample, so you have to make homogeneous. There is an air gap, right? This should have not have been there as per sir's presentation, but this sample we only have this much. So we only have 138 grams of sample. So that is why we have. But again, it has reached equilibrium. This has been packed in 2021. So no problem about other interferences. Now once this is this clean, we open the detector, keep the sample inside, and close it and lock it. So this opening is not done. We don't keep it open for not more than unnecessarily. As soon as it is done, we have to close it. So no dust that enters here. So that is the same reason why we are wearing this footwear. We don't allow outside footwear to come in. So this much is clear, right? Clean. Filter or this clean room. It's not really necessary, but again, it's expensive. Can do. So suppose we want to do that. So this is, see, even if there is a dust inside, you will get a spectrum. While background correction, why we are doing background correction? To eradicate these kind of problems. So we can remove those interferences. But again, we don't want that interferences to go inside at all. So that is why we are doing this. Okay? You can remove. Yeah, by background correction. So then your minimum detection activity will go up. So that what happens is that suppose if you are giving me a sediment sample,
but the background is taken well ahead.
No, that is why we have to take background every 15 days or every 1 month. So you can't do background once in a while in that case. Okay, background correction, background once in a while is very important in that case. Okay, so I hope I have sorted your doubts. And again, what will happen? Suppose background is high, you have your samples are very small, 5 grams. The ocean core samples sometimes we get it is like 5 gram or 10 gram. Now I keep the same sample inside. My MDA formula depends upon efficiency, activity, weight. Weight is less, so MDA goes up, and then you have time. Okay, so lower the weight, my minimum detectable activity goes up. So that is why I have to keep and it is directly proportional to the background counts. So lower the background counts, lower the MDA, but lower the weight, higher the MDA. So for all these kind of samples, we have to keep background as low as possible. Okay, I hope I'm clear now. Yes? Okay, now the sample is kept inside. I will again do the same thing as I did over there. Detector 1, clear the sample and start counting. So now counting time I have given here is over 60,000 seconds. Okay, but you can see why I have given so much. So let us wait till 100 seconds, okay, and see how the spectrum is forming. See, it's around 30 seconds. Can you see any kind of peaks here? Sorry, close. Can you see any kind of peaks now? 30 seconds. Yes, uranium source. This one is called as RGU. It's an IAEA, International Atomic Energy Agency certified reference material. It is supplied from them, and it was done in. So the spectrum.
They should handle themselves.
Yes, sir. I'm just showing them first, and then I'll give the spectrum to them. Yeah. So you can see that even for almost 69 seconds, I cannot get any kind of spectrum, right? There is one peak over here, small peak, but this is an source. If you have your sample, you will get still a flat line. So that is why we have to keep for longer counting period. So 30,000. So if you don't get a peak at 30,000, what do you do? You increase the time, 60,000. If you don't get a peak for 60,000, try more. If you are sure it is there. If it is not there,
Depends on what?
what?
Depends on half-life or something.
Which one?
This peak time, like when you get this peak.
No. It does not depend. It depends upon the concentration of the radionuclide in your sample. Okay. Suppose if the radionuclide concentration is high in your sample, you can keep lower the time. Yeah.
ಅವರಿಗೆ ಸ್ವಲ್ಪ ಇಂಪಾರ್ಟೆನ್ಸ್ ಕೊಡಿ, ಅವ್ರನ್ನ ನಿಲ್ತಾ ಇಟ್ಕೊಂಡು
Okay.
ಅವರಿಗೆ
ಹಾಂ
ಅವ್ರನ್ನ ಸ್ವಲ್ಪ ಇನ್ವಾಲ್ವ್ ಮಾಡ್ಕೊಳ್ಳಿ ಅಂತ ಯಾರನ್ನು ಎಕ್ಸ್ಪರ್ಟ್
ಓಕೆ ಅವ್ರ ಹತ್ರ ಕೇಳಿದೆ, ಅವ್ರು ಅಲ್ಲೇ ನಿಲ್ತಾರೆ ಹೇಳಿದ್ರು. ಇಲ್ಲ ಅವರೊಂದು 2 ಡೌಟ್ ಹೇಳಿದ್ರು. ಓಕೆ, ಸೊ ವೇರ್ ವಾಸ್ ಐ?
So it depends on concentration.
Yeah, it depends upon the concentration of.
You know that in your sample how much concentration is there. So
That
you
way,
must fix
trial and
that.
error.
That fixing is depend on what? Like you are
See, I think sir can answer that. You want to answer it? He is asking, how do I know how much time should I count for?
For unknown sample.
For unknown sample.
How the counting time is fixed?
Before using gamma ray spectrometry, you can use, for example, Geiger counters to check the overall activity of the sample.
Yes.
That's one point. But typically, environmental samples, they contain
Very low.
very low amounts of radionuclides, so the measurement time should be quite long.
Quite low. So you start with, like, let us say you start with 30,000 seconds. You don't get peak. Increase the time, 60,000 seconds.
Generally, see, for example, if you don't have any fixed time, suppose
See,
60,000 seconds you have,
Yeah.
and if anything you are not getting, we will be again counting it for
No. We will start from that 60,000 seconds.
Okay.
I hope so. I have given it for 60,000 seconds, right? Now after the 60,000 second, I'm still not getting. I just change it to, for example, I'll stop
Then it
here.
will continue to
Yes. So I'll stop here. So I hope we assume that it is 60,000 is done. MCA acquire setup. I'll give you 1 lakh seconds. Okay. Now it is set to 1 lakh seconds. So it will continue from where it was left. I need not start it from 0. Okay. Yeah.
Okay.
So we give some seconds. We have basically 30,000 and 60,000 as our standard. 30,000, if you don't get, we increase the time to 60,000. If you don't get, still we don't get, usually we say that it is less than, we calculate the minimum detectable activity and we say that it is less than the minimum detectable activity for that time. Okay, again, minimum detectable activity is dependent upon your time. So when we are saying minimum, reporting minimum detectable activity of your sample, you have to say for the size of the bottle, it is dependent upon the geometry of the bottle, weight of the bottle and time. For example, if I'm saying, see, you can see here, minimum detectable activity for 210 lead is 1.7 becquerel per kg for 300 gram and 60,000 seconds. This is how you will report it. Okay. So let us start. So I will give 4 of you can come here, 4 of you can come there. So I hope why we are not giving you a spectrum that is analyzed right now. We will give you a spectrum that has been analyzed previously. Okay, is that fine? So 4 of you can come here, 4 of you can settle there, 4 of you can settle there. So I think that would be 12, and one can join one of the teams. So I will give you uranium spectrum. Okay. Standard search. Yes. Wait. Yes. Okay. So 4 of you can sit here. Don't do anything. I'll let you know what to do. Okay. Okay. Take a chair and settle down. Maybe I don't think so. Everyone will have chair. but one or two can sit in and the rest can stand. Yeah. Or else we can bring chairs.
One more question.
Yeah.
There are several small points when you
Yeah.
zoom in.
Yeah.
What are those?
I will tell you. I will tell you. We will explain it one by one. Okay. You can take a chair and sit here.
Is this branch?
I will explain later. Okay. ಅದು ಬೇಡ ತೆಗೀರಿ ಅದಲ್ಲೇ ಇಡಿ. We will use the loaded spectrum. Or else I'll have to do the same thing again and again. Okay? Yeah. I will show you thorium spectrum. No, we'll start with uranium, and then we'll do thorium. Then we'll do rest of the cesium and potassium will come in the spectrum itself. Okay? So no uranium. ಅಲ್ಲಿ ಒಮ್ಮೆ ನೋಡಿ ಅಂತ ಮಾಡ್ತಿಲ್ಲ ಅಂತ. Okay, so you have your spectrum. 4 of you can sit here. Okay, take the chair. 4 of you can sit here. I will let you know what to do. One minute, sir. Sir, I will let you know. I will let you know what to do. Just give me 2 seconds. Yes, okay. Okay, please sit down. Okay, you can take these chairs.
Is it so that all these spectra are same?
Yes, all 3 spectrums are same sample, same geometry, and almost similar time, I guess, 30,000 seconds. So we will. I think someone can use this chair. Okay. Okay. So, sir, can you explain to them what to do?
Yes, if they want to ask.
Okay.
I do not want to automatically interfere.
Okay. So, you can bring the chairs from that lab and sit down. I think that would be better. I think you can bring the chairs from there. Extra chairs you can add and sit down so that. Yeah. No, you'll have to. So give me space to come and explain, and then.
Now you tell what
Yeah,
you have to do.
yeah.
Next
You
step
go and
what we
explain
have
to them. ROI clear ಮಾಡಲಿ ಮತ್ತೆ ROI calculate ಮಾಡಲಿಕ್ಕೆ. Okay. So I will explain to them how to set the region of interest. Okay, then they will calculate the counts and then they will calculate the efficiency. Okay. So first, can please listen here. So the first thing that we are going to do here, Vaishak, one. Yeah. So the first thing what we are going to do here right now is calculate the counts under a curve. Okay, under a spectrum. For example, you have what I have given you uranium peaks, all three of you. So you will calculate what and all peaks can you get under uranium peak. Can you please tell me?
Bismuth 240,
Bismuth 214, yes. Lead 214, yes. And yes, lead 210. Okay, lead 210, bismuth 214, and lead 214. Okay, these three peaks you can calculate. So let us see how to do that. Okay, so for that, what you have to do is that you have to calculate the region of, we have to set the region of interest and calculate the area under the curve. So I will do it for one peak. For the next peak, you will have to do it. Okay, you can start with that. Okay, so I have already set the region of interest. So I will clear all the region of interest. Okay. Now we can start.
these are all predefined and you had done it. Huh?
Yes.
Sir,
yes.
please take it, sir.
No, fine. Yeah. Just give me a second. Okay. Now, this is 30,000. See, counting time is over here. So if you get confused, just check here. You have counting time is 30,000 seconds. Dead time is 0.17%. So all counting characteristics are good. Okay. Now what you have to do? I'll do it for lead 210, rest peaks you do it. So whatever the peaks are there. So as sir has asked me, so there are so many peaks, right? As you had seen in the list, there are so many radionuclides for bismuth 214, lead 214 and all. But I don't need all those peaks. If I find two good peaks, that is enough. So that is why I have taken the peaks with maximum abundance. The rest of the peaks you can see here. See, these are together. These are all together. Which one?
No, sir.
This one. This one.
No, this is a, sir, this channel, this is the count recorded. This is the count, sir. This is the energy. So here it is recorded as a point. So this means you have to count 100, 200. So more counts are recorded means it is looking separated. It is looking what you will call raised.
Yeah, so this is the counts per this channel. I hope you remember channel yesterday. So this energy, so let me start from here. So this energy 45.6 is having 1146 counts. Okay. So the next one is a 1174. So next one is a 1263. So you can see that as the count increases, this will look elevated. So those are the points. Understood? So we want to identify how many such points are there. Counts, yeah. So how many? So area we have to calculate. This is actually a Gaussian curve. So let us see how we can do it for this one. Okay. Okay. So I will do it down, and this is your zoom. Okay. So you can do here, down, up, down, and you can do this one. Okay. Up, down. So you can do. So now when I want to set the peak properly, I want to look at the bottom of the peak perfectly. Okay. So now you can see the bottom of the peak. Now you want to move this one. So suppose I have kept it somewhere over there. You can't find it, right? So move this here and bring both the points to the where you want it to be. Okay. Okay. Now you set up. So is this okay? Is this point setting up okay? Yeah, that is what. So this is where the peak gets down. So when the peak gets down in the both sides, again it will rise, sir. So which is the bottommost point, that is what we have to determine. Yeah. So this is the, see, here after this point, it is again rising, correct? So that if I go down, then it will go all over. Yeah. So here I can put here, I can or put here. Anything is fine. So I will, here this one is okay, or at least this one is also okay. Yes, sir. I can actually put here. This is fine, correct? This is fine, this is fine. Or I can also increase it because I can correct it from background. If there is additional counts, I can correct it from background.
Same thing you have to use in the background also. Same channels.
As short as possible. No, some people see there. Some people use centroid plus or minus 5 channel, something like that. But this is just like as low as possible. Wherever there is a dip, I can even use this one. This will not make any difference.
This is manual, no? So everyone will identify the different this higher and lower peaks.
Yeah. So you just have to identify one lower point because this will get subtracted in your background. If there is additional peaks that you have counted, additional counts are there, it will get separated. You don't have to worry. Now I will do display ROI, add ROI. So this is set. Okay. Now you can check the counts here.
How you did it? Okay.
So display ROI. So I
But you have to mark it. Na?
mark these two this thing.
How to mark
Sir, select it by mouse. Select this one. So when you get this, yeah, one click. Cursor. Yeah. Cursor. So see.
click? Huh?
Right click, left click, left click.
Second right.
No. Left click and move.
Okay,
Left click and move.
Add to some portion.
Okay. For example, now I'll tell you easier method. I will do easier method. Okay.
Different software will use different methods.
Okay. No, I will do this. I want this peak. Okay. This one I use left click and bring it over here and press Control L. Control L will bring the left marker. Then Control R will become the right marker. So we usually when it is coming to the right, left and right will come together. When it's going to the left, right and left will come together. So if you
Yes, sir.
yes.
Yes, it varies.
We are using the Syntispec, sir, for the same gamma.
But basically it is same. Basically it is same.
Working process, sir.
Yeah.
But the system of operation will be different for different software.
Software will be.
Whenever you get
So can you do this? Can you do this? Can you do this?
Can you simultaneously select several peaks or one by one?
One by one you have to select, add ROI and then go for example, I have added this ROI.
Yeah, you completely
Okay.
show for one.
I've done this ROI. So now if I plus minus, it will go to the first one. So this is why we are selecting ROI. Okay, just do this.
Sir, is there any option to, in that particular display, like display, then you have to take all the spectrum for ROI
No.
in our Syntispec?
No, I think you are telling about automatic peak fitting.
That is there, but we'll do it manually right now. Okay.
Some software, now recent softwares are coming with
Mark
automatic peak
left side
section.
and right side. How to mark?
I will come, sir. I think you can manage this. Yes. Yeah.
Control L and control.
One by one you bring. Yes, sir. What doubt?
How to mark left side and
Okay,
right side?
I'll clear this all. First clear all the. Please don't stand near to this, please. One general instruction: please don't stand next to this area because suppose you just go like this and something changes. Okay, so keep one chair here. So I think it's better. This is manual, so something goes turns off. It is difficult. Okay, now what I do, sir, you can also watch. Yeah. So I will clear all the pre-saved region of interest. So I'll clear everything. Everything is cleared. Now it is as fresh as how we get from a spectrum. Now what I will do is that, so the first peak is LED 210, 46.5. So let us go to the first peak. First peak, right? So can you see the peak over here? So I can do this one also. So you have options here. You have magnification box over here, and then there is a scroller over here. So it magnifies the region of interest. Okay, now once this is done, so let us say marker is somewhere over here. Okay, how do you bring the marker? So you either take the mouse, select the leftmost marker, click this one and drag it. It's not come. Okay, drag it. But then sometimes it is over this side, somewhere or far away, and you can't drag it all the way from here to here. So what we do, we just select this left end, some point, and press Control L
L.
or Control R. Control L will bring the left marker, Control R will bring the right marker. That's it.
Clear.
Yeah.
Okay.
Thank you, sir. Okay. Now what we do? Now we select this spectrum. Okay. I might. So I'll just do it smaller and smaller. So now it is much clearer. So is this clear? Is this fine? The lower and both side it is lower. The peak should drop and then it should come level or it should increase. Can you see this? So for this peak I can select this and this. Okay. So I'm selecting these two peaks. Okay. And display ROI, add ROI. So that ROI is selected. Now you do that. So this is for 46.5. Now you check the area. Okay. 34,154.
We did
Okay.
it already.
Yeah. Now now you go for the next one.
So next one again clear.
No. Don't clear. Don't clear.
Just dragging the.
Drag and go to just go.
Okay.
For example, next which peak do you want? Look at the alphabetical order. 46.5. Next one is 238. So let us go to 238.
Is the energy calibration correct here?
Yes,
Okay.
it is correct. So basically, once energy calibration is done, can forget it. You don't have to do it once in a while because this won't change much. So now 236, right? 238. 238 is here. Correct.
But it's 242. It's
No. 1 minute. Yeah. I think 238 we don't get much. I think it's 242. Yeah. I will leave that radionuclide. Yeah. That is not the energy calibration is correct, but I usually don't take lead 212. Yeah. So I take actinium and thallium. So let's check the next one. Which one? 295. 295 is there here. This is 295, sir. 295.6. It's correct. So lead 214 we don't get 212 we don't get much. Now what you do? You want to bring your markers, correct? You brought it. Okay. Now you mark it. You take it this one as low as possible. Okay. You can even put here, no problem. Because then once you do this, once you complete this, you let me know. Once you do all the ROIs, then we can calculate background. So background we use the same ROIs. Okay. So this is control R. And then you can also select insert. Insert will do that.
But I think there are, if there is a slight changes to
Left,
part,
no
the area
problem.
will change whether
Yeah, area will change, but we can correct it using background correction.
Is it assuming linear baseline in this case?
No, it's actually logarithmic, but it is actually correcting it actually.
Yes, but I mean that from this point to this point, it should be linear.
Yes.
All right.
So
So basically, this is not a background. This one. This is like a baseline. Background is as
different.
I thought in that.
no background we have. So once we select this, we use the same RAI to background. Background there is already one peak. So 1 minute. So for example, 1 minute.
Centroid is 295.6. That is the energy.
Okay. So I have background over here. So this is my background.
For that energy region, we have to
Yeah,
take
we
again.
add that spectrum to this one. The region of interest we add to this one, and then calculate the background for the same peak.
So it's automatically done.
Yes.
Yeah. All right.
So actually, automatically also can be done, but here I'm teaching the manually. So first you finish this one, then we can do the background correction. Okay.
All right. Thanks.
Thanks a lot, sir. Why? So is it clear here?
You can zoom it.
No. Did you tell them about control L and control R? Okay. Insert brings that. Okay.
Now I have marked the peak which I want. Now what I do,
So how do you do it in your lab then? Spectra marking.
So we have an automated analysis process that calculates
Okay. 1 minute. Yeah. Yes. Yeah. Yeah.
automatically calculates the peak areas. However, what I will explain in some of my presentations how we do it. But we do, in fact, we don't use this ROI method.
Okay.
We use peak fitting.
Oh, okay.
It's a different way.
Yeah.
Of course, the result is more or less same.
Same.
But for example, in case of 186 peak, then
Then
you
it's-
have to be very careful
I-
about
I-
the fitting.
I don't use 186 peak at all.
Yeah.
I take it. I take it for a comparison between my lead and 214 lead and bismuth values and compare it with it. And if it is not the same, I use the other 3 peaks and average it.
Yeah. For uranium, 235, I normally use 164.
Okay.
It's the best peak because there are no other interferences.
Oh, 165.
164, 5, something like
Okay.
that.
But we don't get uranium 235 here much.
Yeah, all right.
I have never seen uranium 235 in the peak, or I have not noticed it.
Yeah.
I should rather check it once in a while.
Yeah. But use that peak if you want to analyze uranium. I think it's best.
164.
Yeah.
Yes. Thanks a lot.
Of course, there is another option. If you are not measuring 235, then you can calculate it on the basis of uranium 238.
8. Yeah. But uranium 238 again, HPGe is not the best instrument to calculate uranium 238 because we cannot ensure the equilibrium between uranium and radium. So we do uranium in water. There is another equipment I can show you later. We have mineral analyzer in water using a fluorimeter method, and there is a fluorimeter. And for other things, we have to go for HPG. Alpha spectrometer.
What we are doing in Stuck, we constantly analyze uranium. It's, I think it's not a problem. Okay, there are problems in some cases, but there are some special cases. So we are analyzing 238 by using this protactinium peak 1001.
Okay.
But the activity of thorium 234 at 63 KAB, they should
Uranium 238 we don't calculate. For which one? Uranium 238 we don't calculate. Only these. Only these. Yeah, it is. Yeah, yeah.
100 divided by 3000, 100 divided by abundance.
35.
Whether
Yeah.
you get cesium,
You check if you are getting
we are
cesium.
not getting
Then there is no cesium. Okay. Uranium RGU might not have cesium.
This is bismuth.
That is bismuth 604, 619. Huh? Yes, but uranium peak is not there. Uranium as a peak, uranium 238 as a peak, I think there is one at 64 or something. 64, 63.
50 some.
Yeah, but it is merged with other peaks. So we cannot calculate uranium directly. So you can only. Huh? That is radium 226. So see, I'll tell you the difference. So you have uranium 238. It gives proactinium, all those things, all this. Then it comes to radium 226. Correct. From radium 26, it will go to radon 222. Okay. From here, it will come to bismuth 214 and lead 214. So we ensure these two are in equilibrium by keeping it to 27 days. Okay. So now using these, we calculate radium 226. So, but we don't know whether these are in equilibrium, radium and uranium. So we cannot say that it is uranium-238. We give the results for radium-226. I hope you understood. If these are equal, if uranium and radium-226 concentration are in equilibrium, then I can say it is uranium-238. But until and unless, we cannot say that, because there is no gamma emitting radionuclides that is as good in between.
What our practice, sir, that is sodium iodide reactor. So that is thorium is that is calculated as a line level.
Okay, that is actinium-220.
Actinium.
Yeah.
Then uranium is that's equal with bismuth.
1007.
Once it is done, we are storing the RO. RO store. So we have to name it.
Bismuth 214.
Bismuth 214 at 1120, right?
1120.
That is actually radium, as I told you. You cannot say that is uranium. You cannot say that is uranium unless you know these two are equal. Uranium and radium are equal, you cannot say that it is uranium. Bismuth 214 gives you radium-226 activity. Okay? Yeah, you cannot say it is uranium. You can say it is uranium 100%. But uranium, you cannot say it is uranium. 1 minute. Vaishak, let them do. Let them do. ಅವ್ರು ಮಾಡಲಿ ಅಂತ ಆಯ್ತಾ ಬ್ಯಾಕ್ಗ್ರೌಂಡ್ ಸೊ ಕೌಂಟಿಂಗ್ ಟೈಮ್ ಡಿಡ್ ದೇ ಚೆಕ್ counting time? Okay, 1 minute, I'll come. Just look at the peak, I'll come. Yeah. ಹಾಂ ಹೌದು ಈಗೆಂತಾಯ್ತು
ಅಲ್ಲಿ ಎಲ್ಲ ಇದ್ದಾರೆ ಸ್ಯಾಂಪಲ್ ಇಡಬೇಡ ಅಂತ ಕೇಳ್ತಿದ್ದಾರೆ
ಯಾರು
ಅಲ್ಲಿ ನಾನು ಸ್ಯಾಂಪಲ್ ಮತ್ತೆ
ನಾನು ಬರ್ತೇನೆ ಸ್ಯಾಂಪಲ್ ಬರ್ತೇನೆ
Information you will get it automatically. Just all this left marker, right marker, centroid. What is centroid? Peak. 634 is the centroid. Yeah, peak. Area is area. Got it? These are, see what you get here is specific for this software. And if you use some other software, for example, Artec, or you use DSC spectrum, DSC. Then the report window will differ. That's why you should be knowing what you are doing. If, of course, there is a software which doesn't give anything like this, then you should be able to manage that. So that you should be knowing from where to take the counts, how to take the counts. In our time, when I was a student, we had what is called single channel analyzer, and then we had 1K multi-channel analyzer. So what you used to write, we used to have a book which is 100 times this, and I used to write like this. Channel number 612, 622, counting up to 640, and I used to write the counts down. Then now software has become very user-friendly. It gives. That's why students of today are much blessed with technology rather than what technology. Technology goes means they cannot do it manually. Yeah. So this is what. Basically, this is what area is. What is integral is. And then we used to do the counter contribution for ours. Right, come. Yeah, I was telling them how to take the count. I was instructing them how to read the spectrum.
ROI comes.
You already know how to
All of you have seen the live spectrum acquiring? Yes. They have seen, is it? Cesium and cobalt? Yes. So note down these things. Tomorrow when Roy talks, he will be doing what are the different efficiency corrections we have to do. How you evaluate spectrum like this. That is the advanced, that is what we meant by advanced. Now you are in the basic level. So you have about 12 hours from